In this video, we're going to discuss a lot about quadratic equations, how to solve them using many different techniques. So first, let's figure out exactly what a quadratic equation is. Our definition says that a quadratic equation is an equation of the form ax squared plus bx plus c equals 0. And the first way we're going to practice solving these quadratic equations is using something called the zero product property. Which just says that if n times m is equal to 0, then n equals 0 or m equals 0. This just says that if you have two things multiplying together and you get 0, then one of the things has to be 0. It is very important to note that this property only works when it's set equal to 0. It's the zero product property. If you don't have a 0 on one side of the equation, you cannot use this property. So let's start solving some quadratic equations using this property. When you're using this property to solve a quadratic, you generally are going to use factoring to figure out your answers to the quadratic equation. So for example, let's solve y squared plus 3y equals 0. And first, I want to point out that this is a quadratic equation. It uses y instead of x, but it's just a variable, so it doesn't matter what we call it. I don't have a plus c term in this particular quadratic equation, but that's okay. That just means that in that ax squared plus bx plus c definition, our c just happens to be 0. So to solve this, I want to rewrite it so it looks like my zero product property. I notice I have a y in common with both of my terms, so I'm going to factor out a y. Now factoring is the opposite of distribution. So if I factor out that y, I should have a y plus 3 left behind in the parentheses. Now I have two things multiplying together and the product equals 0. So using the zero product property, either y is equal to 0 or y plus 3 equals 0. And then y equals 0 is one of my solutions. My other solution I get by moving the 3 to the other side and get y equals -3. So I got two solutions to this quadratic equation. Let's do another one. This one's going to be a little bit tougher. We have 10 times 3x squared minus 13x is equal to -40. Now, I have a product over here, but I can't use that zero product property because this is not equal to 0. So I have to do some other algebra before I can solve this problem. And we have some choices. I can start by distributing this 10 and then adding the 40 to the other side. That could work. Or I can divide both sides by 10 and then move whatever I get on that side over. And I think I'm going to do that because it'll make my numbers a little bit smaller. So I'm going to divide both sides of this equation by 10. When I do that, I get 3x squared minus 13x equals -4. Now, in order to get this in the correct form to use the zero product property, I have to add 4 to the other side. And right now, this is not factored, so I can't use my zero product property. I have to factor this to a product, and then I can use that property. And we're going to factor this using the AC method. The AC method says we need to find two numbers that multiply to A times C and add to my B. So in this particular problem, A times C is going to be 3 times 4. So there's A, there's C. So I'm trying to multiply to 3 times 4, which is 12, and add up to B, which is negative 13. So you want to list things that multiply to 12 and find the correct combination that will add up to negative 13. One thing I noticed right away is that 1 and 12 multiply to 12. And if I make them both negative, negative 1 times negative 12 is still 12. And negative 1 plus negative 12 is negative 13. Those are the numbers that I want. Once you have those numbers, the way you factor this using this method, you take your middle number here and split it up using the two numbers we just found. So I'm going to rewrite this as 3x squared, and I'm going to do a minus 1x and minus 12x. Those are the two numbers I found, and a plus 4. And now we get to factor this by grouping. To factor by grouping, you look at just two terms at a time and pull out what they have in common. So when I look at my first two terms, I have 3x squared minus x. What they have in common is an x. So I'm going to pull out that common x, which leaves me with 3x minus 1. Now I look at my next two terms. They have a 4 in common, and I have a minus sign in the front, so I'm going to actually do a minus 4. When I pull out a minus 4, I will have a 3x and a minus 1 left. This is a good sign. When you're factoring, notice I have 3x minus 1 and 3x minus 1. They match. So now I'm going to pull out what those guys have in common, which is 3x minus 1. And my other factor is everything left behind, x and minus 4. Now I'm finally set up to use the zero product property. So since these two things multiply together to get 0, I know that either 3x minus 1 is 0 or x minus 4 is 0. Solving the first one, we get 3x equals 1, so x is 1/3. And solving the second equation, we just add 4 to get x equals 4. And I have those two solutions. All right, so that's how you use the zero product property. It all comes down to factoring and then setting each factor equal to 0. That's not the only way to solve quadratic equations, though. It happens to be my favorite way when I'm able to use it, but there are other techniques we can use. The next technique we're going to talk about is the square root property. So the square root property says that if x squared is equal to some number k, then x equals plus or minus the square root of k. This just says you can take the square root of both sides of your equation. When you take a square root of both sides, you need to use that plus or minus, because there are two possible solutions to this, the positive square root and the negative square root. So let's do some examples where we use this property. We will solve 2c squared plus 80 equals 0. That's not quite in the correct form to be able to use this property yet, but we can make it in the correct form. I'm going to subtract 80 to get 2c squared equals negative 80. And then I'm going to divide by 2, and then it will be in the proper form. So when I divide by 2, we get c squared equals negative 40. And now I'm ready to take the square root of both sides. And I get c equals plus or minus the square root of negative 40. And now we have a little more work to do. We know how to simplify the square root of negative 40. We just learned about complex numbers in our previous video. So the first thing I'm going to do is rewrite this as plus or minus I times the square root of 40. And now all I have to do is simplify that square root of 40 as much as I can. 40 is the same thing as 4 times 10. 4 is 2 times 2. 10 is 2 times 5. So when I circle my pairs, I have a 2 that gets to come out, but this 2 and that 5, or in other words, that 10, is still stuck underneath the root. So I get c equals 2, well, plus or minus 2i times the square root of 10. All right, let's do another one using this property. Let's solve the quadratic equation t plus 4 in parentheses squared equals 24. And now your first instinct might be to try to distribute that t plus 4 in parentheses squared. But we're going to use the square root property to solve this instead. I can take the square root of both sides of my equation to get t plus 4 equals plus or minus the square root of 24. Now let's simplify that square root of 24. 24 is the same thing as 6 times 4. 6 is 2 times 3. 4 is 2 times 2. So I have a pair of 2's, that 2 gets to come out of the square root, and the guys that don't have a pair stay underneath the square root as a 6. So I get t plus 4 equals plus or minus 2 square root of 6. And now all I have to do to solve for t is subtract 4 from both sides of the equation. And I'm going to write that as negative 4 plus or minus 2 square root 6. And there's my answer. So that's how you use the square root property to solve a quadratic equation. So far we've covered factoring and the zero product property, and now we've done the square root property. Another way to solve quadratic equations is by completing the square. Now this tends to not be a very popular method, but it's still good to learn it because in our next section, when we work on graphing quadratics, it comes in handy to write our quadratics in a very nice form for graphing. So completing the square is still something you should learn how to do. Here are the steps for how to complete the square. First step, divide both sides of your equation by a. Remember, your a is the number that's multiplied on your x squared. The whole reason we're doing that is just to make sure that the number multiplied on our x squared is just going to be a 1. Step 2, isolate the variable terms on one side. So anything that has an x goes on one side, and everything without an x goes on the other side. Step 3 is the step that's actually called completing the square. You are going to add your b over 2 squared to both sides. And I'm just putting a note here. This is our new b. I'm not talking about b from the very beginning of the problem. I'm talking about that number multiplied on your x term after you've already done all these previous steps. So it's possible it's a different number in front of x than it was at the very beginning, but you should use whatever number is in front of your x divided by 2 and squared. After you do that, we get to factor. And then use the square root property. So the whole goal of completing the square is to take an equation and write it as something in parentheses squared equals a number. And then you're able to take a square root of both sides and solve for your variable. So let's do an example where we use this completing the square process. So example, let's solve x squared minus 2 equals 8x by completing the square. All right, so what we have to do first is divide everything by our a. In this particular problem, though, my a is just 1. So when I divide everything by 1, I'm still going to have my same exact equation. My next step is to isolate all of the variable terms on one side. I'm going to bring them to the left. So I will have x squared minus 8x, and I have to move my 2 over to the other side. X squared minus 8x equals 2. And now it's that weird step. So here's what I have. And we are supposed to, according to step 3, add b over 2 squared to both sides of this equation. So I'm going to add my b, which is negative 8 over 2, squared to both sides of my equation. Notice that since I added the same thing to both sides of the equation, I did not change my problem. So what is negative 8 over 2 squared? Well, negative 8 over 2 is negative 4. Negative 4 squared is positive 16. So what we have now is x squared minus 8x plus 16 equals 2 plus 16, which is 18. And now I'm supposed to factor this left side. And it should factor as x plus or minus some number in parentheses squared. So when I factor this, I should have x plus or minus something in parentheses squared. So I just need to figure out what that something is. So I'm going to need whatever I'm adding or subtracting to my x to multiply to 16 and add to negative 8. Well, what's going to work there is a negative 4 and a negative 4. So that's x minus 4 in parentheses squared. If you don't believe me, go ahead and try to distribute that back out, and you should be right back where we are here. Now, here's a little shortcut for you. This number that I put inside of my factored form, that number is always going to be my b over 2 before I squared it. Notice I had negative 8 over 2, which is negative 4. That's what goes right there. So it's whatever you had here prior to squaring it that is your special number that goes in the factored form. Now that this is factored, I can solve it with my square root property. Take a square root of both sides. to get x minus 4 equals plus or minus the square root of 18. Now I just have to simplify that square root and add 4 to the other side. So to simplify the square root, 18 is the same thing as 9 times 2, and 9 is 3 times 3. So I get x minus 4 equals plus or minus, the 3 gets to come outside of the root, and the 2 is stuck underneath. And all I have to do to finish it up is add 4 to the other side to get 4 plus or minus 3 root 2. And those are my answers. X equals 4 plus 3 root 2 and x equals 4 minus 3 root 2. So completing the square has a lot of steps and it's pretty involved. But again, this is a skill that comes in handy when you have to graph these things. So it's a very good skill to learn. Let's do another one where we have to complete the square, and it's going to be uglier than what we've already done. So example, let's solve negative 3x squared plus 5x minus 7 equals 0 by completing the square. Now remember, the first step is to divide everything by a. This time my a is negative 3, so I actually have to do this step. When I divide everything in my equation by negative 3, I get x squared minus 5 over 3x plus 7 over 3 equals 0. And now I have to isolate my terms that have the variables. So I'm going to move the 7/3 to the other side. X squared minus 5/3 x equals negative 7/3. And I left all of the space here in my equation because I know my next step is doing that, adding my b over 2 squared. So remember, the b over 2 that we're going to be looking at is using my new b, negative 5/3. So I'm adding my negative 5/3 over 2, that's negative 5/6 squared, to both sides of this equation. Now what is negative 5 over 6 in parentheses squared? Well, that's 25 over 36. Remember, you square the top and square the bottom. So we get x squared minus 5/3 x plus 25 over 36 is equal to negative 7/3 plus 25 over 36. So I need to now factor this left-hand side and combine these guys together so that I can actually look at it as one number over there. Now, don't be scared by the factoring on this. Remember, I told us a trick in the last problem for how it factors. It's always going to be x plus or minus something in parentheses squared. And the thing that needs to go inside the parentheses with the x is your b over 2. So in our case, it's minus 5 over 6. And now it's perfectly factored already without even having to think about it too much. If you don't believe it, again, go ahead and distribute all of that back out and you will get exactly what we had here before. Now this right-hand side, in order to add those fractions, I need a common denominator. So it's going to have to be a common denominator of 36. That means I need to multiply this guy by 12 over 12 and then add them together. When I add those fractions together, I will end up with negative 59 over 36. So now I can finish solving this using my square root property. Take a square root of both sides. X minus 5 over 6 equals plus or minus square root of negative 59 over 36. Well, we know how to do square roots of negatives now. We know that's going to give us an I. So I have x minus 5 over 6 equals plus or minus I square root of 59 over 36. Now, if we try to simplify this, that square root of 59 is not going to simplify at all. But in the denominator, square root of 36 is 6. So I can take care of that part and get x minus 5, 6 equals plus or minus, I have square root of 59 over 6 times my I. All I have to do to finish the problem up then is add 5, 6 to the other side of the equation, and I get my final answer of x equals 5, 6 plus or minus square root of 59 over 6 times I. So that was a much more complicated completing the square example, but it still just follows those same steps. So as long as you know those steps, you should be able to complete the square on any of the problems that you have to solve a quadratic equation for. All right, so now we have solved our quadratic equations by factoring and using the zero product property, by using the square root property, and by completing the square. Another way to solve a quadratic equation is by using what's called the quadratic formula. So the quadratic formula says that the solutions of a quadratic equation, ax squared plus bx plus c equals 0, are given by x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, which is a pretty long and complicated formula, but it does have the benefit of always working. Things like factoring, sometimes it's very difficult to factor, but this quadratic formula is much more of a plug and chug type of way to solve a problem. So let's go ahead and do a problem solving with this quadratic formula. Let's solve 5 over 12 x squared minus 1 over 2x plus 1 over 4 equals 0. And I'm going to let you know, right now, if we really wanted to, we could plug in a equals 5/12, b equals negative a half, and c equals 1/4 into this quadratic formula and get the right answers. But that is not a good time. When we have all these terrible fractions in the problem, it's much nicer if we can first change the way the formula, our equation looks, so that it doesn't have fractions all over the place. The way I can do that is if I multiply every single thing in my equation by 12, it'll clear all of my fractions. So if I multiply everything by 12, I get 5x squared minus 6x plus 3 equals 0. And now if I use the quadratic formula, it will still get me the same solutions, but now I'm working with nice whole numbers from my a, b, and c, so it should be a little easier to work the formula. Now, plugging these into the formula, I need the opposite of b. So b is negative 6, opposite of b would be positive 6. Plus or minus my square root of b squared, so negative 6 squared, minus 4 times my A times my C. So that's minus 4 times 5 times 3, all divided by 2A, 2 times 5. And all I have to do to get my solutions is just simplify this mess. So underneath that square root, I have a negative 6 in parentheses squared. That's 36. So far I have x equals 6 plus or minus a square root of 36 minus 4 times 5 times 3. Well, 4 times 5 is 20, times 3 is 60, so I have 36 minus 60. And in the denominator, 2 times 5 is 10. Now, 36 minus 60 is negative 24. So x is equal to 6 plus or minus the square root of negative 24 all over 10. We know the square root of negative 24 is I times the square root of 24. And to simplify that square root of 24, we know 24 is 4 times 6. So I have 2 times 2 and 2 times 3. This means that I have a 2 that gets to come out of the root, and that 2 times 3 stays underneath the root. And we get x equals 6 plus or minus 2I times the square root of 6 all over 10. And I can simplify this and write it in the form a plus bi if I split it into 2 fractions and then simplify as much as I can. So splitting it up, I have x equals 6 over 10 plus or minus 2 root 6 over 10 times my I. Simplifying my fractions as much as I possibly can, I get x equals 3 over 5 plus or minus the square root of 6 over 5 times I. So that's how you use the quadratic formula. I actually like the quadratic formula quite a bit because, like I already said, it works all the time, even on things that don't factor nicely. So there is something very special about the quadratic formula as well. There's a part of the quadratic formula that will tell you how many answers you have to the problem and what type of numbers those solutions are. And that is called the discriminant. So the discriminant in your quadratic formula is b squared minus 4ac. That's the part that goes underneath the square root in the formula. And this discriminant tells us the number and type of solutions to a quadratic equation. So if your b squared minus 4ac is positive, so it's bigger than 0, you are going to get 2 real solutions. If your b squared minus 4ac is exactly equal to 0, you get 1 real solution. And the only other possibility is if that b squared minus 4ac is less than 0. If b squared minus 4ac is less than 0, you have 2 non-real solutions. So those cases, you're going to end up with i's in your answer. So for example, in our previous example, our b squared minus 4ac ended up equaling negative, what was it, negative 24, which is less than 0. So that would have two non-real solutions. And we actually solved that example all the way through. Remember the answer that we had? We had 3/5 plus or minus the square root of 6 over 5 times I. So that I makes our solutions non-real. That plus or minus indicates that we have two different solutions, one that uses plus and one that uses minus. More examples. Determine the number and type of solutions to 25x squared equals 10x minus 1 and x squared plus 10x equals negative 9. So notice the way that this problem is phrased, it's not asking us to actually solve these equations. We just need to find out how many solutions there are and are they real or not real. So we can just use the discriminant. Let's start with the first problem, 25x squared equals 10x minus 1. And we should rewrite this so this whole thing is equal to 0, so it's very clear what A, B, and C are. If I move everything over to the left side, 25x squared minus 10x plus 1 equals 0. So let's look at our discriminant, b squared minus 4ac. B squared is negative 10 squared minus 4. My A is 25 and my C is 1. So I get 100 minus 100, which is equal to 0. So since my discriminant is exactly equal to 0, that means that I have one real solution. Using the discriminant does not tell you what the solution is, but it just tells you how many solutions there are and if they're real or not real. Let's try the other one. The other one was x squared plus 10x equals negative 9. So again, I'm going to bring everything over to this left side before we look at the discriminant. My discriminant is b squared minus 4ac. B is 10, so I get 10 squared minus 4 times my a, which is 1, times my c, which is 9. This is 100 minus 36, which is 64. The important thing is it's something larger than 0. So since my discriminant is positive, I know this means I have two real solutions. But again, the discriminant does not tell you what the solutions are, just how many solutions you have and if they're real or not real. All right, just to finish up this video, we're going to do two very short examples that we're solving a quadratic equation for a particular variable. So some form of an equation that has more than one variable in it, but one of the variables has a squared term. So let's solve for v in the equation e equals 1/2 mv squared, and we're saying v is a positive number. Well, we need to just not be scared by all of the letters in this problem. We're still just trying to get v by itself, and we know how to do that. The first thing I personally would do is multiply both sides by 2 to get rid of this 1/2. That gets me 2e equals mv squared. If I'm trying to isolate v, I can do that by dividing both sides by m. And now I can use my square root property and take the square root of both sides. Taking the square root, I get plus or minus square root of 2e over m equals v. But at the very beginning of the problem, we were told v is bigger than 0. So that means that my only solution is the positive square root of 2e over m. I can throw away that negative root because v is supposed to be positive, according to the problem statement. All right, that one wasn't too bad. Now let's see if you're really ready. We're going to do a really tricky one. Solve for p. And we have cp squared minus dp equals k. So again, we need to not be scared by all of the letters. Treat them just like numbers. To make this look like a standard quadratic equation, I need to move this k to the other side so that this is equal to 0. And now we have to solve this quadratic equation. I personally would go for the quadratic formula on this. And now they're trying to scare us a little bit by using all these different letters. But when we're using the quadratic formula, it's given to us with A, B, and C. Don't get confused. In the formula, everywhere we see A, we're going to put C, because that's what it is in this problem. The B in the formula is going to be negative D, and the C in the formula is going to be negative K. Very easy to get confused, especially since I have a C in the formula and a C right there, but those are not standing for the same things. So using my quadratic formula, I know P is equal to the opposite of negative D, that's positive D, plus or minus the square root of that negative D squared minus 4 times C times negative K all over 2C. And then I just need to simplify this as much as I can, and it's not going to simplify very far. All that I can do is simplify some things underneath that square root. I get D plus or minus the square root of D squared plus 4CK all over 2C. And that's all we can do because we don't know what D or C or K are. So we can't actually simplify it any further. And these are the solutions. All right, so that's all I have for you on quadratic equations for now. In our next video, we're going to start graphing some quadratic equations and moving on to other polynomial equations in a future video. So I hope you stay tuned for that. If you have questions, drop them below. If you're a current student, you can also email or attend office hours, and I'd be more than happy to help you. I will see you in the next video.